From the serene vantage point of space, Earth appears as a tranquil, blue oasis. But this peaceful facade belies a world of immense energy churning beneath our feet, a dynamic realm of geological activity. Sometimes, when the pressure becomes too great, this energy is unleashed in a sudden and dramatic way, erupting as an earthquake. A sudden, powerful shaking of the ground, a terrifying display of nature's force. Earthquakes are capable of causing rapid and devastating change, altering landscapes and lives in mere seconds. The very ground we trust and depend on can split open without warning, revealing the raw power hidden below. In moments, entire cities can crumble and collapse, and countless lives are thrown into utter chaos, forcing communities to rebuild from the ground up. Earthquakes serve as a stark and humbling reminder of nature's raw, untamed power and its potential for widespread devastation. These seismic events play a crucial role in shaping our planet's geological formations and profoundly affect the course of human civilization. To live safely and minimize the impact of these natural disasters, we must strive to understand the forces that drive them. Our world is not a static, unchanging entity. It's a dynamic system in constant motion, a complex interplay of geological forces. Through scientific inquiry, we can uncover the secrets behind these powerful events, gaining valuable insights into their causes and effects. So let's embark on a journey to explore the science that literally shakes our world, delving into the fascinating field of seismology. What are the underlying mechanisms that cause the ground to tremble and shift with such force? And perhaps more importantly, how can we prepare ourselves and our communities for the inevitable next big quake? The answers to these critical questions begin deep within the Earth, in the complex layers that make up our planet's core. To truly understand the forces behind earthquakes, those ground-shaking events that can reshape landscapes in moments, we must embark on a journey to look deep inside our planet, exploring its hidden realms. Earth isn't a solid, uniform sphere. It's made of distinct layers, each with its own unique properties and role to play. At the very center lies a hot, dense core, a fiery furnace generating immense heat and pressure. Surrounding the core is a swirling mantle, a semi-molten layer where rock slowly churns and convects. And finally, on the surface, we have a thin, brittle crust, the outermost layer that forms the land we inhabit. The mantle's slow, creeping movement, driven by heat from the core, drives much of Earth's geological activity, shaping mountains, forming volcanoes, and triggering earthquakes. The crust, the very ground beneath our feet where we live and build our civilizations, is surprisingly fragile and easily cracked under immense pressure. But it's not one solid, continuous piece stretching across the globe. Instead, it's broken into massive interlocking tectonic plates, like pieces of a giant jigsaw puzzle. These plates float on the semi-molten mantle below, shifting slowly but surely, year by year, driven by the forces deep within the Earth. Their relentless movement shapes continents over millions of years, and more immediately, causes earthquakes when they interact. Where these massive plates meet at their boundaries, the real drama unfolds, as immense forces collide and interact. Collisions that build mountains, separations that create new oceans, and grinding slides between plates along fault lines. All these interactions create the stress, the buildup of energy, that ultimately leads to the sudden release we experience as quakes. These plate boundaries are the stage, the active zones, for Earth's most powerful and destructive events, the earthquakes that can change the course of history. Therefore, understanding these fundamental layers of our planet and the dynamic interplay of tectonic plates is absolutely key to understanding the causes and effects of earthquakes, and ultimately, to mitigating their impact. So let's delve deeper and see how these plates move and interact, setting the stage for seismic activity. Tectonic plates are always on the move, drifting just centimeters each year. Over millions of years, this slow dance reshapes continents and builds mountains. At plate boundaries, immense forces are unleashed. Plates can collide, pull apart, or slide past each other. These interactions create convergent, divergent, and transform boundaries. Pressure builds as rocks bend and stretch until they suddenly snap. This abrupt release sends seismic waves racing through the Earth. The ground shakes, sometimes violently. An earthquake is born. Famous faults like the San Andreas are sites of constant tension. Every quake starts with the movement of these giant plates, but not all earthquakes are the same. Earthquakes vary in depth and origin. Shallow quakes near the surface are often the most destructive. Deep focus quakes start far below, their energy weakened by distance. Sometimes human activity, like mining or filling reservoirs, triggers small tremors called induced seismicity. Scientists use seismographs to detect and record ground motion. These instruments create seismograms, visual records of each quake. Magnitude measures a quake's strength. The moment magnitude scale is now the standard. These numbers help us compare quakes and assess their impact. By studying seismic data, we learn how to prepare for future events. But what happens when the ground actually shakes? Earthquakes, with their immense power, can dramatically reshape landscapes, altering the very face of our planet. They leave behind a visible record of nature's force. They are capable of raising mountains, pushing the earth upwards in a display of tectonic strength. Earthquakes can also lead to shifting coastlines, permanently changing the boundary between land and sea. The impact on coastal communities can be profound, and, tragically, they are often responsible for triggering landslides or tsunamis, unleashing further devastation. These secondary effects can be just as destructive as the initial quake. For people, the impact is immediate. Lives are disrupted in an instant, and the world changes around them. Buildings collapse, once safe havens turning into dangerous piles of rubble. Roads break, severing vital transportation links and hindering rescue efforts. And essential services fail, leaving communities without power, water, and communication when they need it most. Recovery can be long and difficult, a slow process of rebuilding lives and communities from the ground up. But we're not powerless. Even in the face of such overwhelming force, we have the capacity to prepare and respond. Knowledge is our best defense. Understanding the risks and how to mitigate them is crucial. If you feel shaking, it's time to act quickly and decisively. Drop, cover, and hold on. This simple action can significantly increase your chances of survival. Stay away from windows, which can shatter and cause serious injury, and heavy objects that could fall and cause harm. Keep an emergency kit ready, stocked with essential supplies to help you survive in the immediate aftermath. And practice safety steps so that you and your family know what to do when an earthquake strikes. Science helps us map risk zones, identifying areas that are more prone to seismic activity. Design safer buildings, incorporating features that can withstand the force of earthquakes. And develop early warning systems, providing precious seconds of notice before the ground begins to shake. The more we understand about the causes and effects of earthquakes, the safer we become. Knowledge empowers us to build more resilient communities. Earth is our restless home, a dynamic planet constantly in motion. But by learning its secrets, we can adapt. We can learn to live with the risks and minimize the damage. Together, we can build a more resilient future. A future where communities are better prepared and more able to withstand the impact of earthquakes. Stay curious, stay prepared, always seeking new knowledge and refining our safety measures. And face the tremors together. Because in unity, we find strength and resilience.